We'll proceed in summation and integral calculus. Okay, so we are pursuing discussion in summation and integral calculus. Can I solve a problem? Can I solve a problem by cutting down the problem into many sections? Means if I have a problem, then making the many sections in the problem and solve the problem section by section and then add it. So sub this is called summation. Okay. I believe it is all right. It is simple, right? Means if I have to do something, okay, like to its simplest case, consider that I have to calculate the perimeter of this rectangle. Then how I can calculate perimeter of this rectangle? Then I'll calculate this length. I divide this perimeter of rectangle into four parts. And then length of this plus length of this plus length of this plus length of this. If I add these all four, then I get the full parameter. Makes sense? So I divided into four parts, and more than four part is not required. More than four part is not required. Where more than four part is required, that is a question mark that we will see. What is the surface area of this? Then I can divide it into two parts. One part is this part, and then another part is this part, because this part and this part surface area is same. This part surface area and this part surface area. I have to divide into two parts. Now, to get the surface area of this, then I can further divide it into n into n part. What is n into n part? This is the height, this is the height, and this is the angle. I believe it is evident, right? If I have a surface area, if I have a surface area like this, which rotates, if there is a rotation, then variation in angle can be seen. If there is a height, then variation in the height can be seen. So I have to divide it into n part. If I, okay, height I may not divide because it looks like a straight. Anyway, we'll see this. How I can calculate the circumferences of this circle? Okay, if I am pretty sure about it, that circumference of a circle, if from angle 0, this is x-axis, this is y-axis. Okay, this is x-axis and this is y-axis. This is x-axis, this is y-axis. Now, if someone is sure that between x-axis and y-axis, this is the length. If someone knows how to calculate this length, then he can divide into four parts. This part, this part, this part, and this part, and he can add it, and he would get the circumference of a circle. Okay, but circle circumference is not a straight line. I mean, it is difficult to compute. So, I mean, calculating the length of a straight line is pretty easy, whereas calculating the length of a curved line, it is extremely difficult and it would be inaccurate. Okay, calculating length of a straight line is pretty easy and it is accurate. Calculating the length of a curved line, it is error prone and it is difficult. So if someone wants to calculate the length of the perimeter of a circle, then he would divide into many parts. What is the idea of dividing into many parts? Idea of dividing into many parts is that, like, consider that someone is dividing it into four parts. From here to here, one part, second part, third part, and fourth part. How he is calculating the each part length? Then from this part, this point to this point, he is drawing a straight line, straight line, straight line, straight line, and he is adding all four lines, and he is saying this is the perimeter of a circle. Summation means sigma psi. Summation I equal to 1 to 4. and perimeter of the IS section. That is a straight line. Then someone would say, rather than writing it 4, why don't you write it as n? What do you mean by n? What I mean by n is summation I equal to 1 to n. Instead of 4, write it as n and then perimeter of the ith section where n tends to infinity. Okay, n tends to 100, n tends to 10, n tends to 4. Okay, if someone is saying n tends to 4, then he will get coarse result, not the accurate result. From here to here, he will get coarse result. It will be inaccurate. But he divides into 8 sections and then again he connects by a straight line, but this will be better result. This is what that person is saying who is trying to calculate the parameter. If he divides into 4 sections and then calculate the parameter, he divides into 8 sections and with every section he is taking the begin point and end point and connecting it with a straight line. With a straight line, then 8 line he has to add it. And that 8 line what he is adding, that 8 line length will be more accurate than he is adding 4 lines. Okay, that is the new concept that he understood. That if means this is called approximation. Now he is enthusiastic. Now he is converting it into 16 parts, and then he is adding it. Then he is saying result it even better. Then he's cutting it into dividing it into 32 parts. Result is even better. Then he is dividing it into 64 parts. Result is even better. Then he is dividing into 128 parts. Result is even better. Then he is dividing into 256 parts. Result can be better, but he cannot calculate it. That much is not possible by human. Then he is thinking, if I divide it into 10,000 parts, then result will be more or less accurate only. But how to add the straight line if I divide into 10,000 parts, then each part straight line, how I can add? Consider he divides into infinite parts. Summation I equal to 1 to n where n tends to infinity, parameter of the ith section. Parameter of the ith section. N tends this now he is thinking this is accurate solution even though each part he is connecting begin point end point with a straight line and n tends to infinity. Certainly the result will be accurate, but he does not know how to calculate it. This is the where the switching, transitioning from this repeated summation to integral calculus comes into the picture. We are talking about that transition. How to make the transition from a summation to integral calculus. Anyway, we were going with the concept of calculating the volume of a cylinder. How to calculate the volume of a cylinder through summation. The way I am trying to calculate the circumference of a circle through summation, how I can calculate the volume of a cylinder through summation? Not possible. If it is one dimension, even it is curved, I can bisect it into many parts and then I can proceed to calculate the length. But how I can bisect a volume? Not possible. Okay. To bisect the volume, someone need to understand the orthogonal component that make up the volume, the make up the 3D. Oh, I know. That is x-axis, y-axis and z-axis. They are at 90 degree to each other and they makes a 3D. No one needs more than this. This is sufficient. That is x-axis, y-axis, z-axis. If I compute in this fashion, x-axis, y-axis, z-axis, no need to go for the anything else. Three orthogonal component in 3 dimensions. This is called 3 dimension. 3D, 3D, 3D. 3D means three orthogonal components can address any point in the 3D object. This is called 3D. If I have 2D, then two orthogonal component, I can address any point on 2D, x comma y. If it is 1D, means I can address any point with one coordinate, that is single D. If it is 3D, then different coordinate system comes into the picture. One is x, y, z, that is Cartesian coordinate system. Someone has to think in x-axis like this, y-axis like this, and z-axis like this. If I have a 3D, if I have a 3D, then any point 3D is kept on the xy plane. This 3D is kept on the xy plane. Okay, where the blue mark is the center. This blue mark is the center, origin, 0, comma 0, comma 0. And 3D shape has bottom as a right as a circle and front as a circle, and their area is same. Otherwise, it has a curved surface. It has a curved surface that can be seen. I mean, how I can say this is the curved surface. Anyway, now I have kept the cylinder on this xy plane. This is x-axis, this is y-axis, and this is z-axis. Any point inside this cylinder or on the surface of cylinder, I can write as point P, and that is x, comma y, comma z. Okay, there is also a coordinate system where three lines are 90 degree to each other, but they are not x, y, z. Any three lines, if they cut at 90 degree to each other in a volume fashion, then they can represent the volume uniquely. That is called 3D model. So 3D model doesn't mean that it should be x, y, z only. It can be other thing also. So in cylindrical coordinate system, there are 3D model. If we talk, then it is radius, theta, and z. How to come to, in previous video we have shown it. How to bring a different coordinate system. If I talk about the cylinder, then there are two sides in the cylinder. One side is this and another side is the top side. The top and bottom are same. If I see this, then two things are varying. This is what I am saying. One, I can see that things are varying in angular fashion. There is a circle like this. And one thing is varying in vertical fashion. Looks like this is a surface. Surface means 2D. 2D means two vertical components. Two vertical components can address a surface. And I can see there are two vertical components. One vertical component is along z-axis and one vertical component is along in xy plane only, but in round shape. Makes sense? Arc. If this is the arc, then this is the one line, one coordinate, and this is the z-axis, this is another coordinate. They intersect each other at 90 degree. How you can say like that? They intersect at 90 degree because z-axis is k vector, k unit vector, whereas this arc has, if I talk in Cartesian coordinate system, this arc has I and j vector because it is going only in xy plane. If I do dot product of I plus j with k, it will come to 0. Means z-axis and this arc are at perpendicular to each other. Okay, thank you very much. So I understood. If this is a surface, then it must be represented through a curved line. It must be represented through two orthogonal components. No, 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 no. I have a surface and it can be represented through three unique lines. No, no, we don't want that. 2D surface must be represented uniquely through two orthogonal lines maximum. If you invent one orthogonal line, that is better, but not more than two. Yes, yes, I can do like that. If this is the curve line, if this is the curve line, then this is vertical. This is vertical and this is curve line. These two are perpendicular to each other and they both can represent any point on this surface. Thank you very much. What is your another surface? Okay. Another, this is filled with some battery, very heavy. Another surface is this surface. If this is this surface, then this surface can be represented through what two orthogonal component? What you see? If I see this surface, then there is a perimeter is round. So there is an arc here. That same thing arc you represented here. Yeah, it is same. But here, if you talk about the surface, then it will be represented through this arc. Okay, understood. This is represented through this arc. Thank you very much. What is next? Because if this is 2D, then if it is two dimension, then it needs two different items, two different coordinate to represent it. Okay, in that fashion, if it needs two coordinate to represent it, one is this arc that you said. Thank you very much. Arc. What is another one? Another one is radius. See, if I say this arc, then what is perpendicular to this arc on the surface, right? This line. Everywhere, if I say perpendicular, there is a unique line that is coming into the picture, and that line is going to the center of the circle. From center of this circle, if I move a line, it is perpendicular to this arc. Means this is called radius of this. Means now I found surprisingly this radius line moves in xy plane only. This radius line moves in xy plane only. Means this radius is perpendicular to the arc and this radius is perpendicular to the height z. This arc is perpendicular to the radius, arc is perpendicular to the z. All three are perpendicular to each other. Means I can represent a cylinder through other coordinate system other than Cartesian coordinate system. That is called r, radius, comma, arc. This is the arc, comma, z. In shortcut, people, what is arc? If I talk about this arc, where this is the radius and radius is r, then this arc is if this radius starts from here and it goes theta angle. If radius starts from here and it goes travels theta angle, the length of this arc is r into theta. Then someone can say that if you take any point P here, it can be represented through three orthogonal components as far as cylinder is concerned. What are those three? One is R, one is R theta, and one is Z, that is the height. Okay, R theta, where R is constant and theta is variable. First is R, where R is variable. R, comma, R theta, comma, Z. So in shortcut, people say that cylindrical coordinate system is game of r, theta, and z. But actually, it is r, comma, r, theta, comma, z, where in r, theta, r is constant. This constant and variable, if someone understands, then only he can crack the multivariate calculus. There is something called multivariate calculus, where independent components are more than one, like x and y. This is the dual variate, okay, or bivariate, and then x, y, z, then triple variate, quad variate. Like that, it can be 100 variate also. Okay, in that fashion, someone understand when he is doing differentiation, then which one is constant, which one is variable. These intricacies are not considered in every book or anywhere people see. They just go with, okay, let's do differentiation with this, differentiation with that. If you go for the multivariate, you must understand that what you need to keep constant and why. If someone is keeping some item as constant, then why he is keeping that item as constant? That is the question. Anyway, now when we are calculating the volume of this, then what we did, if this is the circle and it has radius a, then we took any radius r. R is from 0 to a. Maximum r can go. If this is the radius, then this radius length is a, maximum radius of the circle. I am trying to calculate volume of this. Then if I take in between from here to here, not till end, consider this line is length is r. R will go up till a. Okay, up till r. Till r, it will fall inside this sphere till r, and this angle, if I taking this angle, I will move theta. Okay, so it is x-axis little bit, it will rotate, and inside it, just imagine it, r in between, I took between 0 to a, angle between 0 to 2 pi, somewhere I took, and then z I took some height, not full height is h, some z height I take. Now it is whatever I am talking. This is a 3D piece. This is a point inside this. What that point is? Okay, let's say R is A. Then what is point here? If this is x-axis, then I move like this little bit. If I move like this, then I move angle theta. In that fashion, this is point P. This is point P. When it moved like this, then this is point P. If this is point P, then it has angle of theta because it moved angle theta, and height of Z and radius as A. Now just push it inside little bit. Then it will have a radius as R and angle as theta and height as Z. All three are variable. R is variable which will go up to A, and theta is variable which will span to pi, and Z is variable because it will go up to H. Now I am trying to find this volume of this cylinder, volume of this cylinder, volume of this cylinder through summation. Now in that fashion, what we have done in the past video is, now I have three variable now, that is understood. One is R. R will be always horizontal. This is not a spherical coordinate system. R can be anything like this. So R is always horizontal, theta is always horizontal, and height is like this. Now what I did is, the when R is like this, I, instead of taking full A, this is the maximum width of the R, I took anywhere in between R. If this is the R, if this is the R, anywhere in between the R, okay, in that fashion. Now consider from 0 to A. 0 to A, I chop it into n part. 0 to A radius, I am chopping it into n part. Where the ith section, now it has n section. Each section length is A by n, where it is 0 to A by n. Okay, ith section length is R. Makes sense? Consider I make n number of sections along the radius. N chop I do. And then if I talk about each chop length, that is A by n. First chop, second chop, ith chop. Consider length of the ith chop is R, any R, where I will go from 1 to n, then this length R will go from 0 to A. Makes sense? Now this R is actually belongs to ith section where the P point is there. Then actually the length of R is A by n into I, because ith section. Anyway, similarly, if I take this arc, where theta is moving, this arc I chop into n part. I take the jth section. Jth section, if I chop it into n part, I chop it into n part. I take the jth section. I take the jth section. If I have taken ith section on this straight line radius, then I have taken jth section on the circumference. What is length of this jth section? Length of the jth section, what is the angle it makes with the center? Consider it makes the angle with the center is delta theta j. The length of this section is R, because we are at R. We are not at A. A is the full radius which makes the outside surface of a cylinder. We are at R. Then there, that circle we are talking, R into delta theta I, delta theta j. The ith section we are saying, first section, second section, ith section, makes with the center one angle, that is delta theta I. So in that delta theta j, jth section here, the length of this is R into delta theta j. R into delta theta is the j, is the length of this section. Similarly, height I cut into n part. The length of the kth section if I say, then that length of the kth section will be height, that is h by n. Makes sense? Okay, now what is the width of that kth section? Then I can say it is delta zk, where delta z is h by n. What is width of this ith section? Delta r, where delta r equal to a by n. From here it is distance at r. That r distance is actually a by n into I. Similarly, for the height I cut into n part. I talk about the kth section. The height is a by n into k. Width is delta zk. Now if I cut like this, then the cylinder. If I cut like this, then the cylinder is cut into n to the power 3 part. Radius first I chop. If this is the radius, then I chop it into n part. Then if this is the angle 2 pi angle, then I chop that arc into n part, and this is the full height h. I chop into n part. Now there is a small volume will come inside it. If someone can try, take a mud which like people make the brick, and then cut it, make like a cylinder, and then cut in a radius fashion. Okay, cut in that fashion, then cut in angular fashion, then cut like this. There will be n to the power 3 small part will come, where each part if I take, then there is an arc of length r delta theta j. Okay, radius length is delta r. Radius length is delta r ith section, whereas the height length is delta z That's it. Okay, what is volume of this? Then we saw since three are orthogonal to each other, radius and then arc and then height, I can directly multiply it. Okay, I believe it is all right. In that fashion, we say the volume of this small section that belongs to point P, where point P is lying. We talked about point P, right? That is r comma theta r, where r comma r theta comma z, where first r is variable. In r theta r is constant and theta is variable, and z. If I multiply these three, claiming they are at 90 degree to each other, it will give the volume of the I, J and Kth section, that will come as delta Ri into R delta theta J into delta Zk. This is the I, J, Kth section. Now if I sum it, then I'll get the net volume. Summation I equal to 1 to n, summation J equal to 1 to n, summation K equal to 1 to n. R delta Ri delta theta j delta zk. This we saw in the previous video, someone can watch. And from there we brought the volume of a sphere through integral calculus, because n tends to infinity. Number of sections we are making, n tends to infinity. That is not possible to make summation in pen and paper. Someone has to move to integral calculus. Now someone would object here. What is guarantee that volume is multiplication of these three? You took this as a approximation. If I multiply delta r and delta arc, that is r into delta xj, delta theta j, and then height, then it will become volume. What is guarantee that it will become? It will become volume. Okay, no guarantee for it. You just said like that. Okay, can you prove it? Okay. We will use vector fundamental here. That will give the proof. Okay. What are the three sides here? We are talking about meticulously, we are talking about three sides. We are talking about three sides. If I have a delta volume inside this cylinder, where the radius is r, ith section, and then angle is delta theta j, jth section, and height is z, that is kth section. What is the volume of that? That is under question mark. It has three sides. If someone is watching it very meticulously, that subsection of a volume has three sides. One is the delta r side. If I take the horizontal circle, then one is the delta r side. We have cut the radius into n part, and then we have cut the circumference. Okay, we have cut the radius into n part, then we cut the circumference into n part, and we cut the height into n part. Okay, this is what the scenario is. If someone is watching it meticulously, then if this is the cylinder and inside that there is a small volume out there. This volume has an arc, this volume has a radius, and this volume has a height. Makes sense? The small volume inside this, it has an arc, and it has a radius, and it has a height, that is z factor. Three factors are there. Okay, how to calculate the small volume? That is under question mark. Right now, we have taken radius as delta Ri, because if this is the radius, then I have taken the ith section. If this is the circumference, then I have taken the jth section on the circumference. And this length is r into delta theta I, r delta theta j, r jth section. If I take the z, then it is kth section. From height, if I take, then it is kth section, that is z delta zk. I multiplied it. Now consider that the point there, we talked about a point P at the beginning of the discussion. We talked about a point called P, and P is r comma r theta, where r is constant, theta is variable, comma z. That is the point. Now consider that point. So this is the volume we are talking. It has an arc, it has a radius, and it has a height. Height is delta zk, radius is delta r, delta ri, and arc is r delta theta j. Okay, now in that volume, small volume, I have point P, and that P is r comma r theta comma z. That is the point P, where height is, where z varies from 0 to h, r varies from 0 to a, and theta varies from 0 to 2 pi. Understand? Now, how to find volume of this small delta V? How to find volume of this small delta V? If that is the case, to find the volume of small delta V, in that small volume there is a point called P, that is r comma r theta comma z. Now let's take the arc fashion. Now there is a point called P here. There is a point called P here. Okay, and if this is the point P here, then what is position vector of this point? Now this is cylinder. This is cylinder. This is cylinder. If this is cylinder, I have taken any inside it any arbitrary point P. Okay, if I take this arbitrary point P, this is the base of cylinder, and we are here. This is top. This is full cylinder. We are here. This is the point P. Base has origin. If I draw a line like this, that is P vector. That is called P vector. Okay. Now consider that we are in the jth section on the arc. If this is the circle, this is the arc. We are on the jth section. If I divide into n part, we are in the jth section. At this beginning of the jth section, this point P is there. Okay. Now how much this point P moves? What is the next point that it moves? If I move this angle 1 unit, makes sense? 1 unit. What is your 1 unit? 1 unit is 1 pico 10 to the power minus 12 radian. Very small, infinitesimally small. That is 1 unit, not 1 radian. Anyone would be thinking that we are talking about 1 radian, not 1 radian. 1 unit of angle if I move, understandable? There is a small volume section which has an arc, which has a height, and which has a radius. In that section, the beginning point is point P. Beginning point is point P, that we are talking as r comma r theta comma z. That P, how much P moves? How much P moves? If I move 1 unit of angle, means if I say this is point P, and from here to here, this angle is delta theta j. If point P to P, this angle, if it makes point P to another point, it makes angle delta theta j. From point P, how much point P moves? If I move 1 unit of angle, actually angle is delta theta I. If I move 1 unit of angle, that is question now. Okay, let's consider that I move delta theta, not delta theta I, that is difference. I move from here point P, I move an angle of delta theta, and see how much it moves. It moves from point P to another point called P, another point called P1. From point P to another point called P1. If I talk in cylindrical fashion, this is a circle at the XY plane. This is our circle where we have taken the small volume. This is the top circle. Now here, this is the point P. How much this P vector moves? It moves to another point on this Okay, if then P can move anywhere, right? Okay, if I am moving angle theta, then radius I have kept constant. Radius is not changing. Z is constant. Only in XY plane I am moving the radius where radius is constant. If radius is constant and then I am moving it like this from point P. Point P, one 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 angle I am moving, that is delta theta, and see how much P move. P, if I move delta theta, P will move to another point called P1. If this point is R comma R theta comma Z, if this is the point, then this point we are talking, it will be R again, comma R theta plus delta theta plus 1 r into theta plus 1, because we moved we moved delta theta. I'm sorry. Idea is to find, if I move 1 unit of angle, how much the point P is moving along the circle where radius is constant, Z is constant, along the XY plane only. Is to find 1 unit movement in angle brings how many change in the P. I am moving delta theta. If I move delta theta along this, the new point is r comma r theta plus delta theta comma z. First point was r comma r theta comma z. Okay, consider from origin, if I draw a vector, that vector is P1. How much is P1 minus P? How much is P1 minus P? If this is P vector and this is P1 vector, how much P1 minus P? The minus subtraction vector will go along this. What I'm trying to say, if this is P vector, top point is P, and this is P point P from origin P vector. This is point P1 from origin, it is P1 vector. What is P1 vector minus P? That will be, if this is the vector, then that will be this vector. Okay, if I say P1 minus P, movement has happened because of delta theta I movement in the angle from here to here, delta theta I. What is the length of this? This much length is the arc length, but this is a straight line. Someone would say this is a straight line. Okay, this may not be, this will be a straight line, that we will see. Please watch our video, little long video called called length vector. Anyway, whatever the vector it is, this vector, what is the length of this vector? Then it will be P1 minus P magnitude. That is the length of this vector we are interested in. How much point P moved along the arc when Z is constant and R is constant. How much it moved if there is 1 unit of angle moved. That is how much it moved when delta theta angle moved. And delta P by delta theta. Then it will be delta P by delta theta. That will be movement per unit angle. What is delta P? Delta P is P1 minus P magnitude, that is delta P. Or more or less we can say how much it moved, how much that it moved along the arc, how much length it moved along the arc is delta P, that is P1 minus P, delta P, which is a vector, by delta theta. Whatever it comes, magnitude of it, that is per unit angle movement, that much length it moved along the arc. Okay, consider the minuteness of this that we are talking. Okay, this is the circle of the cylinder on xy plane. This is the circle where we are talking, and this is the top circle. We are at any point P, and this from here, this is the P vector. Now on the horizontal side, at any point P which talks about the ith section and angle is delta theta, jth section angle is delta theta j. I moved delta theta. If I move delta theta from here to here, I move. Then this is P, then this is P1. What is P1 minus P? P1 minus P is a vector along this curve. Okay, if I take the magnitude, it will give me the curve length. How much this curve length I moved, if I moved delta theta, that is P1 minus P. Okay, how much curve length moved because of 1 unit of angle movement, delta P1 minus P by delta theta. delta p by delta theta, if I say, then if I move one angle in xy plane or flat, then it will move arc. How much arc it will make? That is delta p by delta theta. Delta p by delta theta, which is a vector. If I take magnitude, then I get the arc length, but that arc length is made if I move one unit of angle change. Then how much the arc length if I move delta theta j of the angle change, multiply it by delta theta j. Means the arc length what we are seeing in this way, which makes the, this is the priceless proof. So if this is the, on the circle, if this is the jth section, and this arc length we are talking, this arc length is delta p by delta theta, magnitude into delta theta j. This is the arc length. If this is the arc length, but okay, if I talk in direct vector, not the magnitude, then it will be delta p by delta theta into delta theta I. This is direct vector. This is the vector that is along the circumference. This is the vector that is along the circumference, because this is p and this is p1. Okay, if I subtract, this will be a line that will be along the circumference. Okay, that is the, that is the vector we got. This is also called length vector. That is the vector I got along the angle. What about radius vector? If I take cross product of radius vector, and this vector, it will give the area that formed on xy plane. Makes sense? We are talking about a small volume. I don't know, I should have shown the volume. I really don't have the volume. Okay, in the name of a small volume, I have like this. Now this is the small volume. If this is the small volume, this, consider this is radius, this is the arc, it forms an area, and then multiply by the height, it forms the small volume. Means this black color is the arc, and this one is the radius, and this is the height. It forms a small volume. If I do cross product of radius vector and arc vector, it gives the area. Makes sense? Cross product of two lines will give the area. Means delta p by delta theta into delta theta I, cross product with delta r. R, there is no problem in calculating the r. How much is the r? Delta r. Means delta p by delta theta into delta theta j, cross product delta ri. Okay, this will give the area. If I multiply by the, if I do dot product, this is called triple, this is, I believe it is called triple dot product. How to calculate volume of a surface, volume of a cubical region? Okay, first calculate the area vector and do dot product with the height vector. You get the volume. This is the common sense. So area vector is delta p by delta theta into delta j vector, cross product delta r vector. That is the area vector. If I do dot product with the height, I get the volume of the ith, jth and kth section. What it is? Delta p by delta theta, delta p by delta theta into delta theta I, delta theta j, cross delta, or I can take other way, delta ri cross product delta p by delta theta into delta theta j. Whatever comes, dot product with delta zk, summation. This is the ith, jth, kth volume. This is completely error free. There is no hypothesis we have taken. Now, what is the volume of this ith, jth question? Summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n, delta p by delta theta, where delta theta I have taken very small, into delta theta j. I'm sorry, delta ri cross product delta p by delta theta into delta theta j. When we calculate the cross product, it will result into a vector, dot product with the height vector, delta z k. If I sum this is for ith, jth section volume. Okay, but what is guaranteed is same as what we did in earlier. That was delta r, r delta theta, and delta z, if someone remember. Will it come to that? It is very different looks like. And then summation of I equal to 1 to n, j equal to 1 to n, k equal to 1 to n. Okay, let's proceed now. If I talk in this fashion, then delta R cross product with the delta P by delta P by delta theta. Okay, delta P by delta theta I, delta theta J, and dot product with the delta Z K. Okay, that is coming. Now, in the calculus, if I have a division, then I can convert into differentiation. Differentiation is nothing but division only, but numerator is dependent upon denominator. Delta P is dependent upon delta theta. Any division I can say it is differentiation, but not all differentiation are division. Any multiplication I can say integral calculus, but not all integral calculus are multiplication. So I can directly say like that. What do you say? Now I can say delta Ri cross product dP by dP, dP by d theta, dP by d theta. Okay, dP by d theta, delta theta j cross product dot delta z k. Okay, this will give the kind of, now I can write it as delta R, delta, I'm sorry, delta R ith section. Now I can rewrite it as delta R into R unit vector, delta R ith section into R unit vector. Okay, because it is in R direction. Cross product dP by d theta, delta theta j, theta unit vector, because it is going in this direction. Dot product with delta z k into k unit vector. Okay, now we can take out delta r, delta theta and delta z outside. Now it will become r unit vector cross product with dP by d theta, theta unit vector. Dot product with the k unit vector into delta Ri, delta theta j into delta zk. That I can write as delta zk. That I can write as delta r delta r delta theta delta z. I'm sorry. Full I can rewrite as summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Now here I can write R unit vector cross product dP by d theta, theta unit vector, dot product with the k unit vector. This will result into function over R theta and z. So we can rewrite as function over R theta and z into delta R delta theta delta R delta z, that will be written as delta R theta z. Now expression come as summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n, function over R theta and z, okay, into delta R theta and z. This leads to a single axis, that is R theta and z. This is x axis. Generally we consider single axis as x axis. Consider an axis that is a hybrid axis, that is R theta and z, and this line, vertical line to it, is not a y axis, function over R theta and z. If that is the case, then if I say I have an integration sign f r theta z, d of r theta z, what it means? If this is r theta z, and this is function over r theta z axis, then there is a line like this, that is actual function over r theta z, that is the height. If I integrate f r theta z with d r theta z, it will give the area underneath it. Make sense? So if I write, I have an expression, integration sign, function over r theta z, dr theta z. Then someone can imagine dr theta z means dr theta z is a line, and on top of it, this is the vertical axis, that is function over r theta z, and there is a continuous curve called function over r theta z. And integration means we are trying to calculate area underneath it. This area underneath it, now consider, underneath will be calculated limit from one limit to another limit. Consider one limit is 0, another limit is some alpha, Now let's say I cut into n to the power 3 part. N to the power 3 section I cut. Each section width is delta delta. What is the delta? If it is x-axis, then each width is delta x. This is what we imagine. Here each width is delta theta rz. Each width is height is function over delta theta rz. Height into this width will give the area of this subsection. If I add area of all the subsection, then it will become integration limit from 0 to alpha and then function over r theta z dr theta z. It is same here. Now instead of 3 summation, I can write summation something, summation beta equal to 1 to n to the power 3 function over r theta z delta r theta z for the beta section. Okay, this is the area of the one particular strip. If I add for all n to the power 3, it will become full-fledged integration, and that will be integration of the r theta z from one point to another point function over r theta z dr theta z. What is function over r theta z? Please watch our previous videos also. What is function over r theta and z? The function over r theta z is r unit vector cross product dp by d theta, theta unit vector, dot k, whatever comes its magnitude, that is the volume, and then d r theta z. What is this? Is the interesting thing that is going on. What is dp by d theta? What is point p? Point p is r. Point p, if I take in Cartesian coordinate, any position vector can be written as xi plus yj plus zk. Here it will be written as r unit vector plus r theta unit vector plus z k unit vector in 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 cylindrical coordinate system. dp by d theta, where r is constant and z is constant because we have taken in a flat surface only, means dr by d theta 0, r theta unit vector means r d theta by d theta, r theta unit vector plus dz by d theta 0. It will come as r theta unit vector, and this side we have r unit vector. R unit vector cross product with r unit vector cross product with r theta unit vector will result in r k unit vector dot product with k unit vector. It will come to r only, r d theta r z, d theta r z d, and in bracket theta r z. It can be dissociated into d theta dr dz because they are orthogonal to each other. Now it becomes r d theta dr dz. Integration, if I take r theta z from begin to end, if I take the integration, then from begin to end, if I say, now theta r and z, they do not vary with each other. I can grow the radius without changing the angle. I can grow in radius without changing the angle. I can move the angle without changing the radius. I can move the z without changing any of them. They are really independent of each other. So r is 0 to a, theta is 0 to 2 pi, z is 0 to h. Okay, so if I talk about the cylinder, then z is 0 to h, r is 0 to a, and angle is 0 to 2 pi, r dr d theta dz. If someone calculate it, then it will become r square by 2, 0 to a square by 2, z is 0 to h, then h a square by 2, d theta is theta 2 pi, 2 pi r square h will be the volume of the cylinder. But this is pretty accurate. Anyway, this explanation and this proof, certainly it is not available in any of the book. Anyone would try. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.